How's it going, everybody? This is Waves back with another video on our channel. Today we're going to be talking about a mutual TLS in a Node.js. Mutual TLS, or in short mTLS, is a method for mutual authentication. mTLS ensures that the parties at each end of the network are who they claim to be by verifying that both have the correct private key. Before we talk about a mutual TLS, let's quickly go through what is TLS. TLS stands for Transport Layer Security. It is an encryption protocol used widely on the internet. TLS, which was formerly called SSL, and you might be familiar with the term SSL, authenticates the server in a client-server connection and encrypts communication between client and a server so that external parties cannot spy on the communication. If you visit google.com, you will see this lock icon in your browser, and if I click on that, it tells me connection is secure with the Google server. So this is basically a TLS connection. So all the traffic from my computer to Google server will be encrypted. So what is mTLS? Well, mTLS is basically a method for mutual authentication. mTLS ensures that the parties at each end of a network connection are who they claim to be by verifying that they both have the correct private key. The information within their respective TLS certificates provides additional verification. mTLS is often used in a zero-trust security framework to verify users, devices, and servers within an organization. It can also help you to secure your APIs. TLS works using a technique called public key cryptography, which relies on a pair of keys, a public key and a private key. Anything that gets encrypted with a public key can be decrypted only with the private key. Therefore, a server that decrypts a message that was encrypted with the public key proves that it possesses the private key. Anyone can view the public key by looking at the domain server or TLS certificate. So if we go to google.com, here you will open developer tools and you'll go to security. You'll see view certificate, and then here you can see who signed the certificate and you can see the details and also take a look at the public key as well. So let's go back to our presentation. So we're going to need a pair of keys, and we will use pair of keys to generate a certificate. Next, we are going to need a TLS handshake. A TLS handshake is a process of verifying TLS certificate and the server possession of a private key. We'll talk about this when we get to the coding part, but for now, once we have a key and a certificate generated, we're going to be using OpenSSL to do that, and then we will be configuring our Node.js server with mTLS. Also, we are going to be writing code to make the request, which is going to be secure request from the client side, which will verify the mutual authentication. Take a look at this diagram, which explains the mTLS handshake from browser to server. So the request goes from a browser to server, then the server responds with hello. It also sends the certificate, which includes the public key. Now, if it's an mTLS configuration done in a server, then it also requests for a client certificate. Once the request goes to client, client sends the certificate. Then client also needs to send the cryptographic info, which is going to be its key. Once sent, then client finished and server finished, and any communication at this point are encrypted. So here's the process of mTLS handshake between browser and web server. We got two files, client.js and server.js. So the code for a server will go into this file, and the code for a client will go in here. I'm also going to be using Node.js 16 version, just to mention. So let's get started by looking at how do we set up a server which accepts the secure connection or secure request from the client. On the server side, we are going to importing HTTPS module from nodejs. Now you are going to be using node colon HTTPS. That's the modern way of importing that. Then we can also import FS, which will be used to read a certificate and a key file. Next, we are going to create a variable. I'm going to name it options. And we'll just leave that as empty. So this is basically going to have all the options for our server. We're going to be using https dot create a server, which will take options. Right now they're empty, but we'll add for some options like key and certificate. Then we're going to be having this callback. I can use this function, and this will have a request and response. Then within our create server, we can just say response right hat 200, and we can for now just send empty object. Next, we're going to be response.end, and we'll just say hello world. This is going to start listening. So listen function from options.port. Okay, our server is set up. As you can see, this is very minimal code required to run the server. To run a server on secure TLS protocol, we're going to need a key, which will be basically created using OpenSSL. Then we need a certificate. At this stage, our server will be running on TLS. It's not ready for mTLS, but there's one little key that we can add later. First of all, let's go and create the key pair and a server certificate. I'll take you to the Chrome. Here, I'll paste a link to the description of this video. I've created this cheat sheet, and this will help you to create a key and a certificate. So generating a key is simple as this. Just copy this line, go back to IDE, I'll open terminal. You can generate key and certificate using OpenSSL, and on a Mac, it's automatically installed out of the box. If you're on Linux, you will have OpenSSL. If not, you can install it. Windows, you can install OpenSSL in your Linux subsystem, or find a way to generate certificate and key pair from Windows operating system. But we are going to be just using this line, and what it does is uses OpenSSL getkey command, and it's gonna spit out this server.key file. I'm gonna press enter, and I'm going to add a passphrase, which is going to be just hello and hello. Now, if you notice, you will have this server.key file, which is your certificate now. Next, we are going to create a CSR, which is like a request for signing a certificate. If you're going to create a multiple certificates, you can create this configuration file. And to create a configuration file, it's pretty straightforward. Just create a file, paste the text from here, and then that will be your configuration. But for now, we don't really need to create that. We're just gonna copy this bit, and I'm gonna go to terminal, and I'm going to paste that. One thing to make sure that you get rid of this this conf flag, because we don't have that file for this bit. So we'll just get rid of this and make sure that your server key matches to what your actually key name is. It's going to spit out this server.csr file. Press enter, and it's going to ask you for a key passphrase, which was hello. And now it is asking you for a few things. First of all, you're going to specify the country name. So I'll just use AU. And the province name, I'll just use Victoria. City name, Melbourne. And the organization, I'll just say my name. And then the unit, I'll just say IT. Common name, which is very, very important. So usually the common name will be matched or validated against the client certificate. So make sure that you put it a proper common name. So at this stage, I'll just say always mirza.com. And the email address, I'm just gonna leave that. Now the password, I will just leave that empty. You'll notice that we have another file, this server.csr file, and this is like the begin server request file that can be used to generate a certificate. Now let's go back to the Chrome. Here is the command to generate a certificate. So let's copy this bit, and then here we are going to paste that command. Now, what type of certificate we're generating, just to make sure that we understand this X509 is the type of certificate that we're creating. We're specifying this expiry for the certificate is going to be 365 days, and then the CSR name, which is this server.css file, a key that will be used, and then the file for a certificate. So you can name whatever you like, but the convention is to use this either PEM extension or CTR. I'll press enter, and it's gonna ask me for a server key passphrase. I'll just say hello. And at this stage, we have three files: a certificate, a CSR file, and the key. Try running this server. So I will click on this play button there. Now we're getting an error. Well, the error is, it says the private key is basically cannot be read. The reason for that is because this private key has a passphrase, so we're going to use a passphrase, and that can be just a string, which was hello. Let's run this file. Now, there is nothing logged on the console, and that's a problem. I'm going to quickly add a callback function, and this callback function is going to say this is going to be listening on options port. Now, because we have not specified options port, it's gonna cause an error. So we'll just use port, and let's just say port is 3000. Okay, now here's an error. It says comma is expected, yes. And now if I run this file, you'll see it says options.port is not a function. Well, that's correct. Why did I even wrote that there? So let's run it, and now it says it's listening on port 3000. Let's go to the Chrome browser, and I'm gonna open a new tab. We'll just do HTTPS localhost 3000, enter, and here you can see it is telling you that the connection is basically not secure. Well, the connection is actually secure. The only reason why it's not basically saying it's secure because we're using a self-signed certificate. Now, if you click on this not secure and it says the certificate is not valid, you can click on this button and that shows you the certificate. And here you can see the certificate was signed by osmuser.com. It's a self-signed certificate, and you can see the details there as well. Now, if you go ahead and then say, I am going to always trust this certificate, then this error will go away. I'm not going to do that because it's a self-signed certificate, and I don't want to just add this certificate to the keychain of the Mac. I can also test it by using a third-party application, which is Postman, or you can actually test. Let's go and use this PAW application. I'm going to create a new request, and this is just going to be localhost 3000, and that would be HTTPS. Okay, get request. Let's enter, and now it says PAW cannot verify the identity of a remote server. Well, that's correct. If you can click on this show certificate, you'll see the certificate is coming back. Click on continue, and then you'll see the hello world is returned. So basically, we've accepted the risk of having a self-signed certificate being validated. Back to the code. Now it's time for us to enable mTLS. So request set to true is the key that will basically request the server, request the client to send its own certificate. Now, if I stop the server and rerun this now, and we go to PAW again, I remember last time we were able to run it. Now, if I send this request, it's going to say, okay, continue. And now it says server requires a client certificate. You see the error there. So basically the error is pretty self-explaining itself. You're going to need a certificate now. To test our client, we're going to be creating a code that will send a certificate to the server and also do a mutual authentication. So we're going to start by importing HTTPS. We'll use the same node colon, and we're going to use this fs to read the certificate for a client. Then we're going to use this options. At this stage, it's pretty much the same thing. If I open the server.js, you can grab this bit and go back to client.js and paste it here. Now this is going to be a different key and a certificate. So I'm going to go to terminal. We're going to go to Chrome, and from the cheat sheet, here's a different key. I'll just copy this and then paste that here. And then this time is going to be client key. So make sure to rename it to client key. Password, we just say password. Okay, you'll see that the client key is there. Oh, okay, so I'm on the wrong folder actually. So I'm going to just open the terminal in this directory, paste that here, and rename this to client.key. Password. Okay, you'll see the client.key is created. Now let's go back and then copy this command and then paste that. We'll first of all get rid of this configuration, and then we're going to be using a key which is going to be client key and then client CSR. Enter, and then password for the key. And at this time we are going to be using a different country name. So I'll just PK state Punjab, and location name, let's just say Lahore. Organization, I'll just say OAS, and then organization unit name, we'll just say IT. Common name is important, so OAS pk.com. And email address, I don't need to do that. Channel and password, nope, I don't need that as well. Now we're going to be copying this command to generate a certificate, and this time it's going to be client.ctr, and the key should be client.key, and this one is going to be a client.ssr as well. Enter, and then you'll see it's going to ask you for the password, and at this stage we have this client CTR as well. So let's change this to client and change the key to client. You're going to need a passphrase. That would be just a password. Okay, here are your options. Then we are going to use this HTTP module, and it has a function called request, and then the request can be sent through using this. So I will go ahead and then just paste the code here. Now at this stage you'll see it is taking options again and then sending a request. So let's go ahead and then make sure that our server is running. So it is running. I'm gonna just run this client as well. Actually, we need to specify where it's gonna go. So we need to first of all do a host name, which is gonna be a localhost, a port, which is going to be 3000, and then the path is just like the root path. Now let's run this file. Let's run it, and it says depth 0 self-signed certificate. So again, there is an error because when we send this certificate, a server basically sees that as, it's not valid. So from the server side, you can validate it by using this CA, and then you can pass in this client.ctr. So all I'm saying here is that when this certificate comes to you, make sure you can just validate it. So let's go ahead and then run the server again. Okay, it is now running. Now let's go to client. And this time we are going to validate the server. So we'll just use this array, and then I'm going to say server. Okay, it is confusing right now, but just give it a second. I'll explain what I'm doing here. So let's run this file now, and now you can see you got the data back, and pretty much everything is just like, now the problem is like there is a server alt name invalid because the both names are not validated properly. That's why it's just like causing an issue. But what we can do is add another key here. We just say reject unauthorized to false. Now when I run this time, now it's basically going to not reject the unauthorized this time. So all of this documentation can be found in Node.js official documentation. But what I'm doing here is, first let's say server. So server CA is basically a list of authorized certificates that you are going to whitelist for your server. So any client that try to connect to your server has this certificate sent, then server will validate it. Okay, now same goes for client. We're saying send this certificate. Okay, but if the server sends the certificate, check it with this list of CAs. If it matches here, that means we know each other, and then just go ahead and then execute the handshake, TLS handshake, and just validate the server. So at this stage, your client and server are mutually authenticating each other with this key and a certificate. Hope you liked the tutorial. If you did, subscribe to the channel and give this video a thumbs up. And I'll speak to you guys in the next one. Cheers.